All right, welcome everyone. Today we're taking a deep dive into something really fundamental, SQL commands. You've shared some notes on SQL, and we're really going to unpack this, right? What these commands are, what they do, and I think most importantly, why they matter when you're talking about interacting with databases. So think of this as, your personal guide to the language of data.
That's a great way to put it. At its core, SQL commands are the instructions that we give to databases. They're how we perform specific tasks, how we run functions, and ultimately how we query the information that's stored within these massive repositories of data.
Okay, so it's not just about storing information, it's about doing something with it, right? I see here that SQL can handle like a whole bunch of actions. You can create these tables to store information, you can add new data, and you can even remove tables entirely.
Right. And not just that, you can actually modify the structure of existing tables, which gives you a lot of flexibility as your data needs evolve. And even more than that, SQL also manages user permissions, so it plays a crucial role in data security as well.
Okay, so it's kind of like, if you think of a database as a giant library, SQL is like the librarian, right? It helps you organize the books, find the information you need, and even controls who can borrow what.
I like that analogy. Yeah, it really captures the essence of what SQL does. It's the language that allows us to communicate effectively with these vast collections of data.
So your notes break down these SQL commands into five main types, right? DDL, DML, DCL, TCL, and DQL. That seems like a pretty good way to organize all of this.
It definitely is. It helps us to understand the different purposes and functions of each type of command, and it makes the whole landscape of SQL a lot less daunting.
All right, so let's start with DDL, data definition language. The key thing I'm getting here is that DDL is all about the structure of our database tables. Like if a database is our house, DDL is the blueprint, right? It defines the rooms and how they're laid out.
Precisely. DDL commands are used to create, modify, and delete database objects,
Hmm.
mainly tables. It's all about setting the foundation of your data storage.
And there's something here about DDL commands being auto-committed. What does that mean exactly?
That's a crucial point. It means that any changes you make using DDL are immediately and permanently saved in the database. There's no going back.
Mm-hmm.
So you need to be very careful and deliberate with DDL commands.
No undo button, huh? All right, well, let's go through the main DDL commands that the notes highlight. We've got create, drop, alter, and truncate.
Okay, so let's start with create. As you might expect, this is used to create new tables. Think of it as building a new room in our house analogy. You need to define its structure, what kind of data it will hold, and how it's organized.
And I see here, an example of the syntax. Create table name, column name, data types. It looks a little bit technical, but I guess it makes sense, right? You're giving the table a name and then defining the columns and what kind of information each column will hold.
Exactly. You're specifying not just the name of the column, but also the data type, like whether it will store text, numbers, dates, and so on. That's how the database knows how to handle the information.
Okay, and then there's do drop. As the name suggests, this is used to delete an entire table. Everything gone, right? The structure, the data, everything, poof.
Yeah, pretty much. Drop table is a very powerful command, and as your notes caution, it's irreversible. Once you drop a table, it's gone for good. So it's important to be absolutely sure that's what you want to do.
So double, triple check before you hit that delete button, right?
Absolutely. It's one of those commands where a little bit of caution goes a long way.
All right, and then we have alter. This is for modifying the structure of a table that already exists.
Right. Let's say you've created a table, but you realize later that you need to add a new column or maybe change the data type of an existing column. That's where alter comes in.
So it's kind of like renovating a room, right? You're not tearing down the whole thing, but you're making changes to its layout or structure.
Yeah, that's a good way to think about it. It gives you that flexibility to adapt your database as your needs change over time.
And I see here that there are different ways to use alter, like you can add a new column, you can modify an existing column, and I'm sure there are other options as well.
Absolutely. Alter table is a very versatile command that lets you make a wide range of structural changes to your tables. It's all about fine-tuning your database to meet your specific needs.
And the last DDL command in our list is truncate. The notes say it's kind of like drop in that it removes data, but it keeps the table structure intact. So it's more like emptying a drawer rather than throwing out the whole cabinet, right?
Exactly. Truncate table is a very efficient way to clear out all the data in a table while keeping its structure. If you need to start fresh with a table, but you don't want to go through the hassle of recreating it from scratch, truncate is your go-to command.
Okay, so that covers DDL, which is all about setting up the structure of our database. Now let's move on to DML, data manipulation language, which sounds like it's where the action really happens.
You're right. DML is where we actually work with the data inside our tables. This is where we add new data, update existing data, and delete data.
And unlike DDL, these commands aren't auto-committed, so we have a chance to undo our actions if we make a mistake, right?
That's right. DML commands are not permanent until we explicitly commit them using a TCL command, which we'll talk about later. This provides a vital safety net when we're working with sensitive data.
Okay, so the main DML commands we have are insert, update, and delete. Let's start with insert, which is used to add new rows of data into a table. I'm looking at the example here. Insert into Java at point, author, subject values, so new, DBMS. It's basically saying, hey, database, add a new row to the Java point table and put so new in the author column and DBMS in the subject column, right?
Exactly. That's the essence of the insert statement. You specify the table you want to add data to, the columns you want to populate, and the values for those columns.
And the notes show that we can either specify the columns, like in that example, or we can just insert values in the order that the columns were defined when we created the table. So we have some flexibility there.
Right. If you're inserting values for all the columns in a table, and you provide them in the correct order, you can skip the step of explicitly naming the columns in your insert statement. If you're only populating some of the columns, or you want to be extra clear about which value goes where, it's always a good practice to include the column names.
Got it. So moving on to update, this command lets us modify existing data in a table. The syntax here is a little bit more involved, but basically we're saying, hey, database, change this value in this column to this new value, but only for rows that meet this condition.
Right. The where clause in the update statement is crucial. It's what ensures that you're only updating the specific rows you want to modify and not every single row in the table.
And I can see how that could be really important, right? Especially if you're dealing with like financial records or something like that. You don't want to accidentally change the wrong information.
Absolutely. The where clause gives you that precision and control when you're updating data. It's a very powerful feature.
All right, and the last of our core DML commands is delete, which is used to, well, delete data. Again, the where clause is key here, right? We need to be very specific about which rows we want to remove.
You got it. Without a where clause, the delete statement will remove all rows from the table, which is really what you want. So be very careful with this one. Always double check your where clause to make sure you're only deleting the data you intend to.
Okay, so we've covered DDL for defining our database structure and DML for manipulating the data within those structures. Now, let's move on to DCL, data control language. This sounds like it's all about security and access control.
That's exactly right. DCL is all about managing who can access what data and what actions they're allowed to perform. It's a crucial part of database administration.
And the main DCL commands we have are grant and revoke. Grant is used to give users specific privileges, and revoke is used to take those privileges away.
Right. For example, you might use grant to give a user permission to read data from a particular table, but not to modify it. And if that user's role changes or they no longer need that access, you can use revoke to remove those permissions.
Okay, so it's like assigning different levels of security clearance to different users. Some users might have full access, while others might only have limited access to certain areas of the database.
That's a good analogy. It's all about maintaining the security and integrity of your data by carefully controlling who can access what.
All right, moving on to TCL, transaction control language. This is a bit more abstract, but it seems like it's about managing these things called transactions. What exactly are transactions in the context of a database?
Think of a transaction as a unit of work. It's a sequence of operations that should be treated as a single atomic unit. For example, if you're transferring money from one bank account to another, that involves multiple steps. Debiting one account, crediting the other account, and updating the transaction log. All of those steps should happen together or not at all.
Okay, so it's kind of like an all or nothing situation. If one part of the transaction fails, the whole thing should be rolled back to prevent inconsistencies in the data.
Exactly, and that's where TCL comes in. The main TCL commands are commit, rollback, and save point.
All right, so commit is used to permanently save all the changes made within a transaction. So if everything goes well, you hit commit, and your changes are written to the database.
Exactly. It's like saying, okay, this transaction is complete, make all these changes permanent.
And rollback is the opposite. If something goes wrong, you hit rollback and it undoes all the changes that were made within the transaction.
Right. It's your safety net.
Yeah.
If an error occurs or you decide that you don't want to proceed with the transaction, rollback allows you to revert the database to its previous state as if the transaction never happened.
And then we have save point, which seems like a more fine-grained way to manage transactions.
Yeah, save point allows you to set markers within a transaction. If something goes wrong later on, you can choose to roll back to a specific save point instead of having to undo the entire transaction. It gives you more control and flexibility when dealing with complex transactions.
Okay, so we've covered DDL, DML, DCL, and TCL. Now the last one is DQL, data query language, and this is all about retrieving data from the database, right?
Absolutely. DQL is what allows you to ask questions of your data and get back the information you need. It's how you extract insights and make sense of the data that's stored in your database.
And the main DQL command, and really the only one we need to worry about, is select.
That's right. Select is the workhorse of DQL. It's how you retrieve specific data from one or more tables based on certain criteria. It's a very powerful and versatile command.
And the syntax seems pretty straightforward, at least at a basic level. Select expressions from tables where conditions. So we're saying, hey, database, give me these values from these tables where these conditions are met.
Exactly. The expressions part specifies the columns you want to retrieve. The from clause tells the database which tables to look in, and the where clause, which is optional, allows you to filter the results based on specific criteria.
Okay, and the notes go into a lot more detail about the different options and clauses we can use with select, like selecting specific columns, selecting all columns using the wildcards that, using logical operators like and, and or to combine conditions, and using the like clause for pattern matching.
Right. The select statement is incredibly versatile. It allows you to specify exactly what data you want, how you want it sorted, and how you want it filtered.
And there are even more advanced features like join operations for combining data from multiple tables, and groupie by Y for aggregating data based on certain columns. It seems like the possibilities are almost endless with select.
They really are.
Right.
Select is the heart of DQL, and mastering it is essential for anyone who wants to work with databases effectively.
Okay, so we've covered a lot of ground here today. We've looked at DDL for defining our database structure, DML for manipulating data, DCL for controlling access, TCL for managing transactions, and DQL for retrieving data. It's been a whirlwind tour of SQL commands.
It has, but hopefully it's given you a good foundation for understanding how SQL works and how you can use it to interact with databases.
Absolutely. And for anyone listening, if you're just getting started with SQL, don't be intimidated by all these different commands and syntax. Just start with the basics and gradually build your knowledge.
Exactly. There are tons of resources available online and in books to help you learn SQL. And remember, the best way to learn is by doing. So set up a test database, experiment with different commands, and see what you can create.
That's great advice. And remember, SQL is the language of data, and data is everywhere these days. So learning SQL is a valuable skill that can open up a lot of doors for you.
Absolutely. Whether you're interested in data analysis, software development, or just understanding how the digital world works, SQL is a skill that's worth investing in.
Thanks for joining us for this deep dive into SQL commands. Hopefully, we've demystified some of the jargon and given you a good starting point for your SQL journey.
My pleasure.
Thanks again.
You're welcome.